Welcome to today's ConSteel webinar. Today's topic is slab reinforcement calculation and export in ConSteel 10. My name is András Herboly. I'm going to hold the presentation. Just for some practical information, a control panel, a GoToWebinar control panel can be hid with the red arrow button. And questions and messages can be sent with the chat options. At the end of the webinar, I will answer them. Few words about the ConSteel fall webinar series. Today's webinar is the first one in this series. Next webinar will be on the 11th of November about the high-level interface between the IDEA connection and ConSteel. Today's webinar content will be the following. At first, I will show you how can you set design parameters for concrete slabs. Then I will show you the analysis and design specialties of slabs. Then the design result visualization and settings will be presented. And finally, I will show you how can you export the reinforcement result to AutoCAD for further detailing and design. Let's go to the ConSteel software. I have created a multi-story building with steel frames and concrete slabs. And let's see how can we determine the necessary reinforcement for concrete slabs according to the Eurocode 2. Concrete slabs can be created with the plate function on the structural member tab. In case of concrete material, a new option is appeared on the dialog. With the 3-dot button, we can create and assign a reinforcement parameter for the slab. On the dialog, we can set the diameters of the rebars in the X and Y direction and on the top and the bottom of the slabs separately. X and Y direction is the local axis of the slab. And here we can set the materials of the rebars also. We can set also the direction of the main rebar. It can be in the X and in the Y direction. The direction, the main direction rebars will be the outside. And we can set the covering also from the edge of the outside of the rebars, and on the top and on the bottom also. With the apply button, we can create the reinforcement parameter. Any number of reinforcement parameter can be saved and created. And with the drop-down menu, we can select any of them and we can assign to the created slab. Reinforcement parameters can be added to any existing slabs or can be modified. If we select the slabs in the property area, we can find the design parameters, and from the drop-down menu, if you created previously, we can select one of them, or with the 3-dot buttons, we can create a new one. Let's create a new reinforcement parameters. Now I use the default rebar diameters in all of the directions and positions and materials also. The main rebar direction is X direction, so those rebars will be the outside, which are in the X direction. and we can set the covering separately, the top and the bottom. Now I use a common 25 millimeter on the top and on the bottom also. With the apply button, create a new reinforcement parameter and design parameter settings, and now I can select from the drop down menu and assign to the selected slabs. Okay, let's move forward. I have applied a simple surface load on the slabs to run analysis. At the end, if you go to the Analysis tab, we are able to run analysis for the models. To reduce the running time, now I'm just run the first order analysis. Okay, the analysis results are performed, and if we have surface analysis result, we can see the forces on surface results and stresses on surface on the upper, middle and lower level. Let's see the forces on surface. You can see the result. You can use the model portions. In case of surface result, we have two result visualization options. The first one is the contour surface. If you click on the color legend with the right mouse button, we can modify the maximum value and the minimum value. In default, the maximum value and the minimum value comes from the model results. So this is the maximum and the minimum value. But if it's necessary, we can modify it manually. Or with the reset automatic plate options, you can go back to the previous settings. Okay. The other option is the discrete color. In this case, we can set if you click with the right mouse button on the color legend, we can set the level of the legend with the up and the down button. With the reset automatic plate button, we can go back to the default settings. All the value of each level can be modified manually. In this case, ConSteel automatically interpolate between the given values, between the highest, the minimum, the lowest, and the manually set values. With the yellow button, we can go back to the automatically calculated default values, and between the red buttons, we can delete any levels from the color legend. Okay, so if we have analyzed results, We can go forward to the global checktop where the design can be run. If you click on the blue arrow button, the usual design dialog is appeared. Because the huge size of the dialog, the design fields of the dialog can be opened and closed. ConSteel automatically open the dialog with the relevant design fields. For example, in this case, the steel and the slab reinforcement design fields are opened. You can see composite column check field is closed. With the calculation button, all of the selected checks will be performed. So now we can see the steel results. If you would like to switch between the performed results, on the right top corner of the user interface of ConSteel, with the drop-down menu, we can switch between the performed design visualizations. So here can be found the slab reinforcement calculations, the four two directions and two positions, at the top in the X direction, at the top in the Y direction, at the bottom of the X and at the bottom of the Y directions. And here we can see the previously set diameter. Okay. In case of reinforcement design, the discrete color legend is used, and two information can be found in this case on the top of the color legend. First one is the necessary reinforcement in the selected direction in square millimeter per meter unit, and the second one, the smaller one, is the necessary distance between the rebars with the previously selected diameter, in this case the 8 millimeters. And of course, with the right mouse button we can open the color legend and the options of the color legend. In case of reinforcement design, we can find two more options. The color legend can be set not just the reinforcement area, but can be set with the reinforcement distance also. And in this case, we can adjust the result visualization to the real wire meshes. Now let's set 4 level with the following parameters. The first is 50 millimeter, it's okay. The second one 100 millimeters. The third one is 150 millimeters. The last one is 250 millimeters, and with the apply button we can modify the visualizations. Here you can see where the value is smaller or higher than the set minimum and maximum value, and the visualization is cross-hatched. So here you can see, for example, in this point, the calculated reinforcement area is higher than the setted maximum. Let's see another result. This is the necessary reinforcement area at the top in the Y direction. Let's see the bottom in the X direction. And let's set the same color legend. settings. Okay. And of course, if we're moving with the mouse on the 3D model, we can see the actual value in every point. And of course, we can use the portion manager if it's necessary, for example, for documentation. Okay, so now this is the slab reinforcement design in ConSteel 10, which will be continuously developed. And let's go forward to the export. So this the export function, which is a very useful new feature, what was introduced in the last ConSteel 10 Service Pack 1 version, is able to with this function, it is able to export the reinforcement visualization to AutoCAD with the XF file. So if we are ready with the concrete slab design and the visualization is set properly, we can go to the File and the Export menu. And here we can find the new options. So this is the reinforcement DXF export. And if we click on it, we will find the following settings. On the right side of the dialog, we can see the previously created model portions and stories, and with the checkbox, we can select which part of the model should be exported. If you leave blank all of them, the whole model will be exported. In the export settings fields, we can set some export settings, such as the target of the drawings. In this case, we have two options. Visualization of the concrete slab design can be exported to one file. In this case, all of the slabs will be exported to one file on the same position as are in ConSteel. For example, in this case, ConSteel will generate a 3D DXF file with the correct position of the slabs. Or we can export the slabs separately to DXF files. In this case, each slabs will be exported to separate DXF file to the DXF drawings. With the coordination settings, we can set the plane of the slabs. We can use the global the plane of the global axis, or we can use the user-defined coordinate system, and also we can set the unit of the concrete palette, because not just the visualization but the concrete palette, the color legend palettes also will be exported to the drawings, and we can set the units. So we can use these two default units for the export. In the scale fields, we are able to set the unit of the drawings. So it could be in the original millimeter, or we can export to centimeter and meter units also. The last option is the scale of the DXF drawings. So here we can set the scale of the exported drawings. Because the drawing export takes a bit long time, so this is the first version of these functions. Of course, it will be improved in the future versions, but currently the export function takes a bit long time. So I previously created the top level of the slab to the ASF. So let's see how the exported drawings is look like. So this is the exported ASF drawings from the top level slab. So the exported drawings contains the geometry of the slabs. So here you can see. So now I exported the slab in millimeter units. So now it's the size is same than in ConSteel. And the results and the 4 reinforcement results visualization are exported to different DSF layers, and we can switch between them. For example, now we are seeing the top results in X directions, but if it's necessary, we can switch to the bottom result if we switch to the AXB layer. It means X directions on the and the results on the bottom level, and the D8 means the rebar diameter is 8 millimeters. And of course, you can see the color legend also exported. Here we can see the units and not just the necessary reinforcement area, but the necessary distance are also exported. Let's see another one. And of course, every result is exported with the previously set color legend. Okay, so currently this is the slab reinforcement design possibilities in ConSteel. As I mentioned, we will continuously develop this part of the software. So if you have any idea, please do not hesitate to send us. For now, I'm done with my today's webinar presentation. I would like to thank you for your attentions. I hope you enjoyed and learned these presentations. Thank you very much, and goodbye.